was at UTARI, UTA's Research Institute, in the field of multi-scale assembly and packaging systems, otherwise known as MAPS. I did my research under Dr. Aditi Das, their head researcher in their advanced manufacturing department. To begin, I'd like to start talking about a little bit about UTARI itself. UTARI is located in Fort Worth. Right now, UTARI is trying to become a global leader in research and development. In the next 4 years, UTARI staff, they want to increase their population to about 400 staff members. Currently, they're at about 36. And also, in the next 4 years, this is what I thought was a bit impressive, they want to increase their internal revenue to about $100 million a year. Currently, we're at about 13. And like I said, all of this entire thing that they want to do is going to be all done by 2017. And a lot of their current research now is in biomedical, robotics, and where I did my research in advanced manufacturing. My role in UTARI wasn't in advanced manufacturing. What I did was designing and constructing a lot of the electrical modules for the project that I was on and other various tasks that they offered me. And I'm not very big in circuit electronics, so this was a bit out of my comfort zone to learn all these new things. And a lot of the beginning stuff that I had to do was inventory, a lot of different components, and I learned the difference between a 0603 resistor and LEDs, 1206 size. And anybody who's worked with those kind of packaging sizes knows that they're extremely small, and one mistake and you can lose an entire reel of components. And that's not very good. But also, I was able to, with a little help from my mentors, I was able to learn a new software called CADSoft Eagle for printed circuit board design. And using that, I was able to create the schematics and all of the layouts that we use for our circuit boards. And as you can see here, this is an example of what a schematic would look like in Eagle. But also after I designed and laid out what the circuit boards would look like, I gave it to my mentor for approval. After that, I'd be tasked with ordering each board and ordering all the components that would go on with the board. Once those took forever to come back in, I'd be tasked with populating each circuit board with all the components necessary, which with some of the boards that I worked on were a bit more complex to hand solder, so these kind of boards could take hours, if not maybe a day or two, to completely fill out. Which brings me to talk about what project I was on at UTARI, which was MAPS. And to start off, MAPS is a system that involves the integration of multiple hardware modules through unique and sophisticated type software and automation to create a process that, as you see, offers the following benefits as cost effectiveness, time efficiency, high repeatability rate, and also eliminates a lot of the human error involved with creating circuit boards. And here you can see a lot of the examples of the different MAPS systems that we have at UTARI. And what MAPS means is basically it can take several different processes like manipulation, dispensing, heating, and inspection, and integrate them all together in a specialized software that we would use LabVIEW or and it would be able to take each one of those processes and make them a bit faster and a bit easier to work out, if more so than if we would have done these all individually. Because, and depending on what type of software we use, we can either control the entire process manually through the computer, or we can take a step up and for our steeper products and our more time sensitive projects, we can automate the entire process and work out more complex boards very quickly. A great example of a more commercial option that we have for MAPS is our Onyx 500 pick and place machine. Now this machine is able to take pick and place, dispensing, heating, and inspection, and be able to automate the entire process to take a more complex board that I would take me to hand solder about a day or two, and be able to complete that entire process within, say, 15 to 30 minutes. it is a bit lengthy in the beginning to actually program the machine, to understand what part is which, the orientation it's in, and the specific placement of each part. But once the entire machine is programmed to know what it needs to do, where things need to go, it becomes a more manageable and cleaner experience. Another thing that Utari is working with and is pretty exciting is the electrohydrodynamic printhead. As it says, the EHD printhead is a new technology that Utari is using that uses electrical fields instead of like thermal or acoustic energy to deliver ink to a surface. But also, the EHD isn't just limited to just delivering ink and normal printing. The EHD can also be used to provide low-cost front-end fabrication for gas sensors and thin film transistors, but it can also be used too for back-end packaging like epoxy dispensing and interconnect printing. Next, I want to show a couple examples of like the products that we created at Utari using various map systems. The first one I want to show you, which I think is a tad impressive, is our microspectrometer. As most of us know, spectrometer is a device that takes in light, breaks it down using into its spectral components using various lenses, mirrors, and a beam splitter. This microspectrometer here uses a ball lens that's about 800 micrometers in diameter, a beam splitter that's about 1,300 micrometers in size, and mirrors that are about 1,000 micrometers by 800 micrometers. And the fully finished spectrometer itself only holds a size of 1 centimeter by 1 centimeter. So we're able to do to keep the full functionality of a regular spectrometer all within a small area. And next thing I want to show you are these more examples of things, the capabilities of map systems by creating these various monuments and structures. You can see the Eiffel Tower. But pretty impressive thing is that, as you can see, most of these structures are about the size of the fingertip, maybe a tad bit bigger. And they get not to say fairly complex, but as you can see with this modular structure, it needs to be quite precise in order to create that stack. And with the map system, it can take every last one of these parts, dispense the exact amount of epoxy or adhesive that would need to be able to create any one of these structures, and still expertly place each part where it needs to go. And also, next I want to talk a little bit about the actual software that goes into the map system, because this is where pretty much everything takes place, because we can have all of the hardware, all your manipulation, all the heating, dispensing, but without the software here, you wouldn't be able to keep that all together. And a lot of what I think is impressive about the software is that you can program in different tasks that will allow you to, say, auto-correct any procedure that may come up with any mistakes that the system does itself. Say, for instance, if it misplaced a part or if a manipulator wasn't able to pick up a part. The various cameras that you see will be able to pick that up and go back and repeat a process just so that you can keep that efficiency and accuracy. So in conclusion, I've shown you about the concepts behind maps, what we hope to accomplish with it, and given examples of various hardwares that we have at Utari and softwares that showcase the many capabilities of this system. And I've showcased maps as a system that can be flexible, accurate, and dependable. And a bit of the future research that we hope to do at Utari is to take these different map systems and integrate them a bit further to take systems like the Onyx 500 and the EHD printhead and integrate them together so we can have one size machine that can accomplish several, if not more tasks all in one process. And a bit of reflections. That was a great picture.
Yeah.
But I'd like to take the time to reflect on my short yet exciting time with Utari and the LSAMP program. First, I'd like to start off with the LSAMP program of Dr. Actison by giving me this opportunity to go and research with Utari. And also, I'd like to thank my mentors at Utari for for educating me in such an innovative way. I went in there pretty much green on circuit design and with very minimal knowledge on soldering, and they gave me new techniques and like programming, the different kinds of software that goes into maps, learning new circuit design so that I can go in and create these kind of complex circuit boards. And also they honed a few of my older skills like soldering. So when I first started off, I'm pretty sure I burned up a few LEDs with my first board. And also 3D modeling, because a lot of the clients, they like to see what the product will look like after everything's done, not what it's going to look like as a schematic or the simple layout. So I was able to go in with different 3D modeling technology or CAD softwares like SolidWorks and be able to show what it's actually going to look like as a final product. But also, I like to thank my family, my mother, my little brother, and my father, because without them, I wouldn't be here right now, and I wouldn't have the opportunity to come to college and be able to participate in these wonderful programs like the LSAMP and work for great people like at Utari. And this was definitely an amazing experience, and given the opportunity, I would love to do it again. Thank you very much for your time.
I'll make a quick comment.
Please.
You know, you actually inspired me. I teach a class called electronic packaging, and the Onyx 500. You know, some of the PCB boards you guys are, you know, like you were involved in. It may be possible to bring the students over there.
Oh, definitely.
Really. So I think I used to participate there. I haven't in a while. But, thanks for inspiring me.
Now, Bishti, I assume our students had a tour of Utari this summer, but I think it's a good idea somehow to expand those tours and perhaps have more of our students from our campus going and visiting. I'm sorry.
And definitely too, because Utari is really, like I said, they're trying to expand to almost
General Lynch,
staff
you could say
members.
something
General
like
Lynch. It's great, man. But they're really open to the more students that they can bring in, because this was their first year using interns, so they were kind of just like throwing us around every which way. Oh, what do we do with you guys? We have help now. So, but they're really a very friendly and open environment. They welcome new students to come in. They're very eager to teach new people. So I would very well recommend any students that are interested in any of these technologies or any of these kind of subjects to apply for an internship. They're extremely open and they're looking for the space.
Well, then, thank you.